For this video, I picked out a problem-solving question on differential equations. Now, this is probably different to 99% of questions that you've done before, so let's get started and see why. It tells you the rate of change of temperature, which is represented by y here. So the rate of change of anything, just before we start, is how it varies with time. So we can straight away form the fact dy by dt. It says it's directly proportional, so not equal to, directly proportional to the difference between the temperature of the water, again that's labeled by capital Y, sorry, just lowercase y, and the room temperature. So the difference means the larger of the two temperatures take away the room temperature. We're going to assume here that the temperature of the water is going to be greater than 20 degrees. It says write down a differential equation for this relationship, and we've almost done that, but what we have here is a directly proportional sign and not an equal sign. If you remember back to GCSE maths, you can replace a directly proportional sign with an equals k or an equals constant, and that same logic can apply here actually. Replacing this with an equals k, we get dy by dt is equal to a constant k multiplied by y minus 20, and that satisfies a differential equation. So that's part A of the question done. Let's now move on to part B. Show that y is equal to 20 plus ae to the power of kt. So straight off the bat, what I realize here is there's a power of kt. The only way you can get that kt is if you keep k on the right hand side of the expression and if you integrate it with respect to t, because the integral of k with respect to t is kt. So let's do that. Let's keep the k on the right hand side and let's remove everything else from the right hand side. So starting off, dividing both sides by y minus 20, you get 1 over y minus 20 dy by dt is all equal to k. And then like I mentioned before, we're going to multiply both sides by dt. So k dt, I don't know why I wrote t, sorry about that. And then you can integrate both sides of the expression. Like I mentioned, integrating k will get you to kt. We're going to deal with the constant later, so don't worry about that. And integrating this, 1 over y minus 20, well, there is a rule in maths that when you integrate a function where the numerator is the differential of the denominator, like here, 1 is the differential of y minus 20 because y differentiates to 1. That will always be ln of the denominator. In this case, it will be ln of this denominator y minus 20. So ln of the modulus of y minus 20 is equal to kt, but then you have to write a plus c. A few students asked me once, when you integrate, don't you end up with constants on both sides? And you do. So this one constant that I've introduced is essentially the constant that you end up with here, take away the constant that you end up with on the left hand side. So it just helps to write out 1 rather than dealing with loads throughout the question. In the expression that it wants us to show, there's only a y, whereas here we have an ln function involved. So what we have to do is apply a power of e, because e to the power of ln y minus 20 would just be equal to y minus 20 for the left hand side. If you'd like me to explain this logarithm rule, just let me know in the comments and I'll make a separate video about that. But the right hand side, you can write that out as e to the power of kt all plus c. Now there is a rule when you're dealing with indices. For example, a to the power of x plus y, you can split that up into a to the power of x multiplied by a to the power of y. Because when you're multiplying indices and the base is the same, you're just adding the powers together, just like I've done here. Using that same logic, we can split up this power into e to the power of kt multiplied by e to the power of c. Now, in order to make it match what it's wanting us to show, what you can see is that the letter capital A replaces the e to the power of c. So you can say something like, let a equals capital A, that is, equal e to the c. And then you can say that y minus 20 is all equal to a e to the power of kt. We're almost done with the question. We just have to add 20 to both sides of the expression, and we do get what we need to get to. So after adding 20, you get to this expression here. I'm not going to bother writing it out, and I'm just going to erase some of this just so we have space for the rest of the question. Okay. Moving on to part C now, it says given the initial temperature is 100 degrees, so straight off the bat, the word initial means we're considering the start of the whole motion, which is when time is equal to 0. So sometimes you might have to infer that from the question. It won't just directly say when t equals 0, and this is an example of where the temperature is 100 degrees. So once again, y is what the temperature is, so we're going to replace y with 100 and make it equal to 20 plus ae to the power of kt. Like I mentioned, t is 0. K times 0 is going to be 0, of course. And then anything to the power of 0 is going to be equal to 1. What we form now is 20 plus a is equal to 100, meaning that a would be equal to 80. Now that we've got the value of a, we can replace the expression here with that value. So y would be equal to 20 plus 80 e to the power of kt. Moving on to the last part of this question, it says after 8 minutes. So although it doesn't specify here, and that is a problem with this question, t is supposed to be the time in minutes, not in seconds. So that means that we can substitute t equals 8 into this expression, and it told us that the y value is 60 at that time. Replacing y with 60, we can make it equal to 20 plus 80e to the power of kt, where t is 8, so 8k. Rearranging now for this to make k the subject, we start by subtracting 20 from both sides. 60 take away 20 is of course 40. You can then divide both sides by 80. 40 divided by 80 is just a half, so you can write a half is equal to e to the power of 8k. You can then apply ln to both sides of the expression, so ln of a half is equal to, okay, so here we can simplify things, ln of e to the power of 8k. There's a rule that tells you can bring the power forward as a coefficient, so you can write this out as 8k ln e. And because ln e is just equal to 1, you can write this out as 8k. To finish off here, we can divide both sides by 8, so you get an eighth of ln a half is equal to k. But we're not quite finished yet, because what we can see here is they added another layer of difficulty to this question. Ln of a half, you can write that as ln of 2 to the power of minus 1, because 2 to the minus 1 is a half. And like I said before, you can take the power forward as a coefficient when you're dealing with logarithms. Applying that same logic here, you can bring this as a power of minus 1, and this becomes minus an eighth ln 2, which then matches what you're asking for in the question. That's everything for this question. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.